Hello, today I'm going to deploy the .NET web application web API, and that's for our backend, and we're going to deploy our front end as our Angular. So I'm going to show you this application first. First, we need to go to our current directory of our backend. We need to test this first. Read cd Batman, the application name is Batman, then .NET build. We need to build first to make sure there's no error. Okay, there's no error, just warnings. Okay, and run this .NET 1. We're going to deploy this application to AWS ECS. I just wanted to show you this local development environment. You need to go to /API/superhero. So this is the API. This is our API. Let's copy this. You can go to this to another browser to show much better. So this is our API. This is our API. You can go back and then in command. This is our backend .NET Web API, and this is our front end. So we can go to our front end, cd Robin, and then ng serve. Before we go in, we need first to configure our environments. As you can see, I already deployed it, but for the startup, we need to get this localhost 5000 to this HTTP, just to make sure it will work in our local environment. Then we will reconfigure it again. We will reconfigure it again for our development environment. Okay, this is the localhost. Okay, you can go and ng serve -o flag o, then just need to wait. So that's it. This is coming from our API. This data is coming from our API, and this is from the API. This is the API, .NET Web API. And I can show you the code. Again, this is our API. This is from our controllers. This is the dummy data from controllers. And then again, at first, if you created a new .NET Web API, I just want to show you this. You need to comment this HTTPS redirection, so that we can configure and build a Docker image in HTTP, because Docker is designed for HTTP only. So we can soon in the future we can configure HTTPS. And then after you comment this, you need to go here, application URL, and you need to remove the HTTPS and just use the HTTP version, localhost, then assign a port mapping, whatever you want. And then you can go before we deploy this, just to make sure we have our, so I already show up the front end and the back end. Now we can go to our NGINX container. This is the NGINX configuration. This is our NGINX. This is the NGINX configuration. This NGINX configuration. Then we have the upstream server. Our upstream server is our .NET Web API. So this is the 127.0.0.1. This means that all localhost. Then 5000. If we deploy this. This is our main configuration file. You need to make sure that you change this. I already test this in Ubuntu Linux, so I'm gonna use a CI/CD pipeline with the use of GitHub Actions. So I'm just going to show you this is the configuration, and this is our Docker file. This is our Docker file, and we can go this the backend, and this is again the Docker file for the backend. Microsoft.NET or SDK Alpine. This is the Alpine version build. Alpine version build for .NET. Okay, and then again we can go to our front end. This is our front end. I can show you this. It's Docker file. This is the Docker file for the front end. Alpine is built by Alpine. It's or multiple builds from Alpine, Node Alpine, and then from Alpine itself can go and expose to 80. That's it. So what we're going to do is to upload this or push this in GitHub repository. So I already created a GitHub repository. You can create your own. You can go GitHub. GitHub. I already created. This is our NGINX. This repository is for NGINX. I can show you this. This is the Docker file of the NGINX. It's just the same from this NGINX. Just the same. This is for the NGINX container, reverse proxy, and this is for the front end. This is the front end. This is the front end. And then this is the backend .NET Web API. So I already created a workflow for each. So I already created a workflow. After you already push a repository here. You need to configure the workflow for our CI/CD pipeline. I already created a workflow. I already built it. So we will build again. We will update this action workflow. I can show you the code, the workflow file, our image. So this is the workflow. We will push our Docker image to ECR, AWS ECR. It's a workflow, same as in our front end Angular. Same as in our front end Angular. Node.js YAML file, and then we will do the same. This is a workflow for our front end, and then this is same as I have here the workflow for our NGINX container configuration. Yes. So what we're going to do is to first go to our AWS. If you don't have an account, you can sign in for an account. You can create your account AWS. If you already have an account, first you need to do is in AWS you need to create a security group. I already created a security group. I just want to show you the security group for this, our application load balancer. This is not just for our application load balancer, it's designed for our whole application. Just want to show you. Yes, this is for our database, and this is for HTTP port 80. HTTP, you need to choose HTTP, search HTTP like this. IPv6, you need to choose IPv6 or HTTP. When you search HTTP, then port 80, then IPv4 something. That's it. I already created it, and you need to create this for your own, like this, like doing this, adding rule something, HTTP, IPv4, IPv4, and then HTTP, IPv6. Then you need to go to MySQL, and you can go IPv4, and that's it. That's how you can make it. You need to name this for systems secure firewall. This basically it's security group. It's a firewall. You can allow traffic to allow traffic for port 80 and 3306 for our database. That's how you can create it, and you can click create security group. Since I already have it, and I'm not going to create it again. Second is you need to create your target for our load balancer. We need to go to our load balancer target groups, create target group, select IP address, and then target group you can name it whatever you want. Batman, from Batman, always choose for IP address because we're going to use our ACS, Elastic Container Service, for our running or orchestrating our Docker containers application, the front end and the back end. They always choose the IP addresses, and then Batman, you go port HTTP port 80, this default IPv4, GP, HTTP, and don't forget about, if you're deploying about the backend, we need to specify a testing API endpoint for your .NET Web API. So, or else it will have an error, or you will not gonna deploy your load balancer attached to your application. So the key point why we're doing this, like, you can go ahead. For me, as you can remember, this is the testing ground. The load balancer will test the web API. If you deploy it, the load balancer will make a GET request. So it is necessary to have a content to the request of load balancer. So it can declare a healthy. At least it means that it can have a request or content. The load balancer can communicate to your application, to the load balancer. Like you can go back, you can assign a specific endpoint, this endpoint, just to test our application by load balancer. Super hero. As you can see, we can go API/superhero. Let's check again. IP address, target group name, Batman, IPv4, HTTP. Our health checks is our health checks to test our application by load balancer API/superhero. Don't forget, this is necessary for your deployment, for checking your application if it's rendering content for your application. You can do whatever you want as long as it can render content to your website or API. Again, you can continue next. Again, you can assign in whatever you want in the last IP address, and then include a spending below. You can go 20, and then create target group. Okay, we already have a target group. We can now create our load balancer. We can then create load balancer. Then we can load balancer is you can name it whatever you want. Batman API, internet facing, IPv4, and you can choose all of it. You can choose 2 or more, or this, because each availability zone is our data center, physical data center. You can choose the security group for our application. We can go in port 80, allow port 80 traffic, and then choose the recently we created a target group. This is a target group. and this application load balancer. Again, I chose the application load balancer for this matter. Like this application load balancer listens to port 80, HTTP port 80, and then that's it. Let's check again about Mansita, internet facing, IPv4, and choose security group and Batman's. Don't forget this. Like, create load balancer. View our load balancer. We need to create, the reason why we need to create our load balancer first, because we need to assign this in our code here in our program.cs. We need to register our front end. We need to register our front end from Batman, and then we need to get the load balancer of this backend to our front end in our environments here. Just need to wait to provision. Still provisioning. Just need to wait until it provision. While provisioning, we need to create another one for our load balancer for our front end. We need to create another target group IP addresses again this is for our front end IP address, and then this target group Robin. This is our front end Robin, HTTP port 80 IP port the same, and then we're not going to assign something because at the beginning we don't need a something endpoint. So at the localhost, at the landing page, we see a data content. This is to this website. So we don't need to assign something endpoint here, unlike in our backend. IP addresses Robin IPv4 here to check. Okay, you can go next and then assign different is 21. Include as pending. Okay. Then 21 is create target group. Already created target group, and then we need to create another one. Yes, our backend is ready, but we need to create a new load balancer, application load balancer for our front end. This is our front end. This is Robin /Angular. Robin/Angular. This is our front end Angular. Internet facing IPv4. Choose again whatever you want, and then application load balancer or security groups, and then create. This is the Robin that we created, the target IPv4 listen support 80. We can leave this and then check again. Okay. Always make sure that this is right. Create load balancer for our front end. So remove this. Since our API, our API load balancer is ready, we can now assign this for our environment variables here in our front end. You can paste here like API URL Batman API. Okay, we're good. Okay, already assigned this. Then let's just wait to provision this one. Let's just wait to provision this one. That will take a minute or more. Wait something. Okay. One thing that you need to consider again you need to go to IAM. You need to make sure you have an access key. While waiting, just want to show you something that you need to consider. Users, I already created a user. This user has a administrative access. I can show you how it created. Like you can put a name like administrator next, attach policies directly, and then administrator access. You can go administrator access, search attach policy, next, and then you will create user. After you will create a user, create user for administrator. After you create administrator, this is our administrator. You need to go to security credential, and then you need to generate where is it? Okay, access key. Create access key for our application command line interface, and then next. I understand recommendation. Next. This is for admin access. Then create access key. That's it. You need to copy this. You need to copy this. Remember to have an access key. This is what we're going to use in our application. You need to copy this. Paste it here. That's it. This is our access key, and this is our access key. This is our what I mean. And this is our access. This is our access secret key. Access secret key. You need to save this in order to use in our GitHub actions, but now I already created it, so we're gonna delete this. Be careful about this. Don't push it in public repository. This is necessary. Since I already have administrator access, so I will delete this. And for this tutorial, you need to save this to use in our command line or any of the use cases. Don't save. Then done. Continue. Okay. Users, I will delete this. I already have it. Administrator. I already have it like this. I just show you how to create an administrator access key and secret. That's it. And then you need to generate your own again, create access key if you want, if you forgot. Again, since I already have it, then let's check this our load balancer. Yes, our load balancer is already visioned. We need to go to our backend. I need to minimize this. We need to go to our backend, and then in .NET, this is, I don't know to other framework, but in .NET you need to register an course origin to be able to secure your API. Then okay, no, forgot something. Be careful about it. You need to paste this like HTTP, Robin, Angular, and the AP Northeast, Amazon. And save it. This is the security features of .NET Web API. You need to register it in order to access our the front end. In order for our application front end access our .NET Web API, need to put this, and then yeah, that's it. You can go back, go Robin. Okay, very good. Again, we need to push a new version of our application. We need to I need to comment this because we're not gonna push this in our Docker Hub. I'm gonna push this in his ECR. I'm gonna comment this. I'm gonna comment this and uncomment this part. I'm gonna push this. Again, if you I mean in your repository, after you choose a action workflow, like you need to choose something like that node. You can choose your own workflow, like you can go node, you can configure this, you can choose, or for me this is for the front end, and then in my back end Batman API, you can choose action. In your workflow, you can choose .NET and search it for the backend web API. You can choose this configure workflow. Yes, since I already have it, so I'm going to configure workflow. After you configure your workflow, you need to go to your directory of your first we need to go to our directory of our backend, cd batman, and then you need to git pull to get the workflow, this workflow. It's gonna take some time, maybe a minute to go. Just already update. But first, before we push our image to our repository again, to our GitHub, we need to create an ECR. AWS ECR, Elastic Container Registry. ECR out. It's Amazon Elastic Container Registry. This is where we need to create a private repository. This is the Batman. These are backend. Backend na lang. Backend. This is our backend. This is a backend repository. Create a backend. Private backend, then create repository. Already created our repository, and then create another repository for our front end. Robin, front end. This is the front end. Then create repository. Already create a repository, and create again our repository for NGINX, for our NGINX container. NGINX, have NGINX, create repository, already have it. Then you can go here and now backend, view push command. You need to copy this and paste it here. Paste it here, and then you need to copy this again to your command. You can go docker build backend, and then after you need to copy this again. Paste it here. Same process. the same process in the front end. This is for the back end. We need to first we log into our AWS with the use of our access key and access secret key, like this is. So first we need to go to GitHub Actions, to GitHub, to configure your AWS access key ID to the secrets variable. Here you need to first to configure here in settings, and then in secrets variable actions you need to create. I already created a no, I'm not yet created a yes, so I can show you this. You need to copy this, you need to copy this, create repository secret, paste it here, access key ID. What I'm going to do is to stop this is for security purposes. I need to we're just gonna post it. Post. I already created the secret for our environment. I mean, this is the repository secret access, and then I'm gonna do again the same thing in our AWS secret access key. So copy, go back, and then I'm gonna post it again. This is for security purposes, don't show up into public. Post. I already created it. This is the most important in order to log in and push build our Docker image to repository Elastic Container Service. Okay, we're already good for this, for our backend. And then the same thing in our front end. We need to configure in front end, and then the NGINX reverse proxy, and I'm gonna configure it in again settings. Go to settings, secrets actions, then the same. I'm gonna post it and post again. Okay, I already created it for our front end. This is a Robin repository already created, key. And then the same as in our NGINX reverse proxy, we need to configure the secrets, action secrets variables. Then the same way, we need to copy this again, and then I'm gonna post again this to. So I already created a AWS access key ID and AWS secret key access key for our variables secrets of GitHub for our GitHub actions. But first you need to consider in general, you can go and always read and write permissions similar to Batman or backend. Settings, actions, general, read and write permissions, go to repositories, to our front end, settings, then actions, general, read and write permissions. Repositories, since we're configure out our secrets to be able to log in and push our repositories to ECR, we can go back here again. We already configure AWS credential secrets. We already done this. We already copied this. We already copy paste from ECR, save it. And then what we're going to do now next is push this. I'm just gonna explain this workflow file. This is .NET. Then my branch is main, to make sure it is main branch. So Ubuntu latest, then action .NET. My .NET version is version 6. restore dependencies, we will restore dependencies, build the dependencies, restore .NET test the application, automatically test the application, and then publish this .NET, and then this is our configuration for building and automatically building and pushing our Docker image to ECR. Now we're going to do now is to push this. Go back to our ECR. As you see, there's no image for backend. So what we're going to do is to git add that just gonna wait. So git commit -m init commit. Okay. Then git push. Sorry, Batman. Just need to wait. Just need to wait something. Just gonna take time to push. Okay, already push. You can refresh this. As you can see, this is our workflow is working. We go to actions. This is what we commit. You can see this workflow. Yes, it will restore dependencies, build our Docker image, publish, log into our AWS ECR. Log into our ECR. Log in, build our Docker image. Just need to wait. Okay, already green, so we can refresh this. Yes, this is our backend image. .NET Batman. Okay, very good. Come back. We can go back. We can now push our front end image the same way we're gonna do. So we can go to our Robin, and then we can go to our GitHub Node.js.yaml. We're going to comment this because we're not gonna push this in Docker Hub, public, open source. I'm just gonna explain this. Build and test our Angular. We're going to latest. The version of the node is 18. Then set up node version, matrix version, install dependencies, npm clean install, npm ci, then we go npm install Angular CLI, then ng build our project, we will build our project, and then we need to comment this to be able to push to our ACR. The same way, you need to go to view push command, copy this, paste it here, paste it here, then paste it here, Docker build for front end, copy again, paste it here, okay. My mistake, Docker tab, okay, copy it, paste it here, okay. Note, don't forget your AWS region. This is the region. You can get the region. You can get the region by this. This is AP Northeast 1 Tokyo. You need to put it here. So that's it for our configuration to build and push our Docker image to ACR for the front end. Ready. Just make sure it is right. Okay. Same. CD. Go back to our main directory, then go to our directory of our front end, and then we need to get the okay, after we get add, get commit, and then we can name whatever we want, front end. Need to first wait. Okay, and then git push. Okay, can go back to stories, Robin. As you can see, there's no image. You go to actions, front end, to install dependencies, install Angular CI. It will install our Node.js. I forgot. I just want to show you, this is the git ignore. It will ignore our unnecessary things for our git version, including this node modules. So it will create our new npm and clean install here to have a new node modules. Then again, automatically build and push our Docker image to ACR here. For now, there's no need to wait this to build. build and push Docker image. Okay, we're ready for our front end. We're going to refresh this. Yes, we already have it. And then for our NGINX container, NGINX, we will do the same. 11 is our NGINX. This is our NGINX Docker file. Okay. cd cd NGINX container. Okay, in a git add dot before we git add, I forgot, we will do the same, our workflow. We will comment this. We'll comment this. After we comment this, we can go to our bottom and just copy the workflow of. We need to just copy this back to our Docker YAML. Paste it here, and then we can go to view push command. Again, we can log in, copy this, paste it here, and go Docker build, NGINX, then copy again. Just gonna build our image, rename our image, and then push. This is the push command. Okay, after we configure this, I already created this. I already configured in our secret variables in GitHub, and already good. Paste it here. Then we need now to push this in our repository in git add dot latest. I'm just gonna wait. Then git commit or commit, not m, commit. Okay. After then git push. We'll git push. for our host proxy. Okay. Just gonna wait. We already push. Let's refresh this. Go to actions. Check out. I'll go to ECR and we'll push or build our Docker image. Okay, ready to go. We can refresh now. We can now refresh this. Now we already have it. Now we already have the repository for our requirement to deploy this in ECS. We can now go and we can now deploy this. Now first we're going to go to our ECS. We need to go to ECS. We need to create a task definition. Create new task definition. This is our back end task definition. Backend. You can go. It's either you can choose this. Check this Amazon EC2 instance or AWS Fargate. Fargate for serverless computing. But in my case, I will use both. If I want to deploy this in different clusters. So what I'm going to do now, I choose this both, and then you need at first, if you don't have for the first time you're gonna use, there is no role here. There's no ECS task execution role. So after you create a task definition, you need to go duplicate this tab. It will create a new role. Then you need to go to IAM. You need to go to IAM roles. By default, AWS will create a default execution role. You need to just comment this, post this later. So first you need to by default, AWS will create a new role for you. So you cannot create a new role manually. It will automatically create by AWS the role. So you need to search for ECS task execution role. Once you're done creating task definitions, you need to create a new revision to assign a task role here. You need to edit the ECS, ECS, choose this ECS task execution role that AWS created. You need to add permission, attach policies, like you will attach policies. Cloud, you need to search for cloud. For monitoring, like where's it? You need to find the CloudWatch. I already added a permission, so it will not be visible. This you need to attach policies, like I do this, like CloudWatch full access, Amazon RDS full access. Then if you need a Amazon S3 access, you can do it. Attach policies. Then you need to add this is one of the most important, Amazon EC2 containers reverse role, because we're gonna run our containers in service but not in by task. So in service, this is the default attached by AWS Amazon ECS task execution role policy. So once you're done adding permissions to this role, ECS task execution role, you will create a new revision and attach this policy, this role After you attach the policies, you need to attach now this role, this ECS execution role, backend. Okay, you can choose what. For me, I'm gonna choose this for one vCPU only, and gonna leave it this as default. You can choose whatever you want depending on your vCPU compatibility. Like okay, so we're done with our role. We need to go and put our NGINX container. NGINX, this is our NGINX. We can go back to our, we can go to our ECR again, ECR. This is the NGINX. Then copy the URI. You need to copy the URI, go back, paste it here. Okay, this is our NGINX image from our ECR, Elastic Container Registry, NGINX. Then it is port 80, you can run in port 80, this is NGINX. And then you need to add another container for our backend. And then you can go, you can name this as backend, you can name this as backend, and then you need to repository, go to your backend image, copy URI, and then paste it here. After the backend, you paste it here. After you paste it here, you need to add port mappings, which is 5000. As you can remember, here in our application, the Batman launch settings 5000. Okay, container port 5000, backend container port 5000. Let's check it out again. This is our backend, AWS Fargate or something. You can choose whatever you want. So Linux operating system, it's x86. Then again, ECS execution role, NGINX, okay, latest, and then backend latest tag, then container port 5000, and then we're good to go. Let's create this task definition. This is already created. Let's check our containers, port 80, these containers, and then our backend. Okay, 5. Then we can now create our cluster. And we need to create first for our front end. This is our front end task. The front end task definition. Front end AWS Fargate, and then you can do whatever you want here in launch type. Just make sure it will be compatible to the cluster, what your infrastructure cluster we're going to use. So front end, then choose again the ECS task execution role. You can choose whatever you want. For me, I'm gonna leave this as default. 1 vCPU, 3 gig memory. Again, this is, I'm gonna name this at front end. Then I'm gonna go back to our repositories. This is go to the front end, copy URI, and then paste it here, latest front end. Then we're gonna leave this as our container port 80. Let's check it again. Front end, it was Fargate, okay, vCPU, ECS task execution role, front end, latest, okay, container port 80. That's it. Okay. Create our task definition. We can check it port 8080. Okay, already created our back end and front end. Now we are going to create our nodes or servers. So create our cluster. We're going to create a cluster. So this is our node. This is our worker. dash nodes. This is worker nodes. It's up to you if you want to use serverless, Fargate, or you can assign your own configuration, customize. For me, I'm gonna use EC2 instance. I'm gonna choose the Amazon Linux 2. I'm gonna choose the M5 M5.large, because M5.large is a AWS or Amazon Intel processor, which is a general purpose processor for our server. And you can assign a desired minimum of your worker nodes. This is the minimum. So in my case, I will choose one worker nodes or one server, so, and it can scale up to 2 worker nodes if there's a high volume of users or workloads, so that it can scale up and scale down depending on user volume. Worker nodes. Okay, now create our cluster. Just need to wait. It's creating. Just need to wait to create our cluster. You can check this in EC2. EC2, you can go EC2. You can view the instance. It's pending now. This is our ECS instance, M5.large. Just pending, it's just creating. Okay. Create. Okay, already created. So it's already created. Okay, as you can see, it's running. It's now running. Need to refresh this. Initializing, status check, initializing. We can now create a service. So we're gonna use service instead of tasks. So service gives you more capacity to create tasks, 2 or more tasks. To create, you need to choose this launch type, EC2. Okay, launch type. We're gonna deploy our backend. This is the launch type. You need to choose the launch type, EC2. Then you can go backend. Choose the family. Latest. Okay, just gonna name this as backend, service name backend. Then you can assign whatever, how many tasks or replica of your nodes, of your containers, running containers. or in Kubernetes pods. Okay, go networking, choose your security group, created security group, load balancing, application load balancer, use existing load balancer, Batman API, use existing listening port. This is recently we created at the first HTTP. Use an existing target group, Batman. Okay, this is our health check path. Get request for our load balancer. You can assign whatever you want. Health check grace period. Let's check again. Launch type EC2 service backend. Our revision is for latest backend. These are tasks. Networking. Use these are security group for our networking. Load balancing. Use existing load balancer backend API. Then choose a container to load balance. We choose this NGINX because NGINX will handle the traffic for our backend, and then our application load balancer will communicate to our NGINX container, and then NGINX container will communicate to our backend web API. And then listener port 80, use an existing target group Batman. Okay, so then create this. You can see there's which will refresh this. Just gonna wait. We're just going to wait. So you see to check pass. Then you can wait to our load balancer. Okay, our backend API is already deployed. This last deploy completed, so we can now test this. Our backend API. Copy this. You can go right. It's our, as you can remember, this is our local environment. We need to assign an API/superhero. The same way here in our deployed application, we need to go to API/superhero. Okay, this is successfully. This is our backend API successfully deployed in our AWS ECS. This is our container running on ECS. Okay, already deployed. Now we need to create another one. This is for our front end. We need to deploy our front end. EC2. We can go EC2 Amazon EC2 again. Launch type EC2, and then our front end. Latest. This is a front end. These are front end. Then you can choose a desired task again. Depends on you, whatever you want, how many it is. Then default. Then choose a security group again. Then load balancing, application load balancer. Use an existing load balancer. Choose the Robin Angular. Choose an existing listener, port 80, then use an existing target group, Robin, and then you can go 70 for health checks seconds. Launch. Let's review launch type EC2 service front end. Then our front end for revision service is front end replica. Our replica is 1, just only one pods or one replica of our container for front end, and then default default subnets, then use an existing security group, and these are our security group. Load balancing, use an existing load balancer, Robin Angular, then choose the container to load balance. This front end 8080, there's nothing here, this one. So listener port 80, HTTP, then use an existing target group, Robin 70, and create. Again, I just want to check. Just want to check our front end. Okay, already put it here. Okay, this is our front end. Just need to wait until it deploys. Okay, deployed, that's completed. So let's test our application and paste it here. Okay, yeah, that's it. So this is our application, our front end already deployed. Both the front end and the back end is already deployed. So this is our web server, our API, and this is our front end, Angular. So this data, this is Spider-Man, name Spider-Man, first name Peter, and last name Parker, place New York, is coming from this API. Name, as you can see, name Spider-Man, first name Peter, last name Parker, place New York, it's coming from the API. As we recently show here in our local environment. So it's working now, and so that's it. This is how we deploy our front end and back end application with the use of AWS ECS. We configure things from NGINX, configure how we can push our Docker, push our code in repository, automatically build our Docker image and push it. Like we use the CI/CD pipelines with the use of GitHub Actions, continuous integration and continuous deployment to our ECR, then from ECR to our ECS, then we create our service and we deploy it. We use a load balancer. That's it. That's how we deploy it. So let's refresh this. So that's it. That's all for today. In the future, I'm going to, as you can see, I'm going to make a certificate manager. Certificate manager. I'm gonna configure the certificate manager and the load balancer to redirect to our HTTPS version of our, or secure version of our website or system. Here we will request a certificate manager, and we're going to first we need to what I mean is we need to first have a domain. We need first to have a domain before we configure a certificate manager. In Route 53, like in Route 53, we need to create a hosted. So after we have a Route 53 domain, and we need to go to Certificate Manager, again Certificate Manager, to have a SSL, TLS, SSL certificate for our domain to be secured. That's it. Stay tuned. I'm gonna continue this video soon and configure the domain and a certificate manager. That's it. Thank you guys for watching. See you soon. Happy DevOps.